Alright, so we're going to have a lot of word problems, and you guys have been shown multiple ways of how to find equivalent ratios and rates. And so there's really two ways we've talked about it. We can use big one, right? We could, if I want to get this down to unit rate, I could simply say 3 divided by 2. 3 divided by 2, and that would give me 1.5. And so I would have 1.5 over 1. And so if this was a rate of dollars to hours, it would be $1.5 to every hour. And see, and I did that through division. That's one pathway that sometimes works. Here, I could have been like, I want to get it down to unit rate, and I could divide it by 10 over 10. And you see how I'm using big 1 to manipulate this, and I would have gotten $3 every hour. Okay? And so there's just these multiple pathways to get to answering what it's going to ask you. And so here in this lesson, I'm going to go through these problems. And so if I was you, I would try to solve them and then watch the short solution. Try to solve it, watch the solution, and see how you're doing. If you get stuck, watch the solution first. So the first step is we got to set these up and set them up as, well, let's see what we have here. Out of 30 students, so we have 30 students, 17 have dogs. Alright, so 17 out of 30, so for every 30 students, there's 17 dogs. Based on these results, predict how many of 300 students in this school have a dog. So what you're doing is you're setting up a proportion, but we're also going to set up an equation. And so we know that there are 17 dogs to 30 students. What's it going to be like if there's 300? So how do we go from here to here? Well, here I think it's a great example of multiplying the top and the bottom by the same quantity, right? By 10 over 10, which is 1. And you can get your answer very quickly, 170 dogs. See that? But look at my strategy. Could I have taken it down to unit rate and then multiplied by 300? Sure. But this was a strategy that looked best here, or at least for me. Look at this one. 1 out of 12 students, I'm going to write that down. 1 out of 12 students at a school shares a locker. So this is students, and this is the one that shares the locker. That's why I have an L. Okay. How many share lockers in a school of 456 students? Wow. So we know that out of every one kid that shares a locker, there are 12 students. Am I saying that right? 1 out of 12 students shares a locker. So here we go. 1 shares. So if we have 456 kids, well, then how many would share a locker? Well, how do you solve that? Well, really it's about what times 12 gets me to here, because we're trying to extend that rate. Well, okay, well I think take 456 divided by 12. What is that? 3, 36, 96, what's that? That's not 8, yeah, it's 8. 96. So it looks like we're multiplying it by 38 over 38, which then gives me 38. Sorry, I'm using an X for an unknown. But do you see what I've done? I'm taking this rate that I have, and then I'm extending it, and what am I multiplying by to get there? Alright, let's take a look at this one. So, what are we doing here? Set up your rates, and then set up the second rate, and try to find what is unknown, your answer. Sabrina jogged 2 miles every 30 minutes. So do you see how I've written out my rate? At this rate, how far would she jog in 90 minutes? So here's 90 minutes, and so, alright. Well, how did I go from here to here? I multiplied by 30, so I must multiply by 30. So that would be 60. So in 60 minutes, she will go, did I do that right? 60 miles. Yeah. Yeah, let's take a look at the next page, 75. So I'm just going to be working through until the time runs out. Ready? So guys, I'm going to say it again. Set up your rate. Set it up equal to the other rate that you're trying to find the unknown part of and solve it. So let's, if 45 cookies, so we have 45 cookies, will serve 15 students. So I set up my rate. How many cookies are needed for 30 students? All right. So we're going to keep the students on the bottom because that's where we're at. We want to know this portion here, right? I need 45 cookies for this. 15 students. Well, what if it's 30? Well, how did I go from here to here? Well, that's easy. Multiply by 2, right? So it's 90. Not by 2, but 2 over 2. Let's try the next one. 4 students, so here's S for students, spent $12 on school lunch. At this rate, so they're saying that the rate's going to continue, find the amount for 10 students. So here we have 10, and this is the amount we don't know. So if there's 10 students, what will it cost? 4 students, it's $12. At this rate, find the amount for 10 students. What do you see here? Do you see how this isn't an easy... and you can never add or subtract. It's really about multiplying and dividing by 1, or big 1. So I'm going to take this pathway. I'm going to simplify this down to what? 1 over 3. So for every 1 student, it costs $3. See what I just did? I simplified it down. Now, can I get to 10 students? Yeah, how? Multiply by 10. Multiply by 10. So that would be $30. So for 10 students, how much would they spend on lunches? $30. Why? Because for 1 student, it's $3. Let's try the next one. Number 3. Clydesdale drinks about 120 gallons, wow, every 4 days. So this is for 4 days, right? Okay. At this rate, which means they're going to continue at this rate, at this rate, about how many gallons of water does the Clydesdale drink in 28 days? Now, if I wanted to, I could make a table, right? See my table? And I could go, all right, well, if in 4 days it does that, in 8 days it'll do 240, right? Because if I increase this by 4, then I must increase this by 140, or multiply by 2 over 2. All right, well, if I increase another 4 days, well, that would be 12, and this would be 360. All right, let's do another 4. That would be 16, and now we're at 480. But do you see how I'm still pretty far away from 28 days? That's why it's really convenient to write it like this. Take my 120 gallons over 4 days, set it equal to 28 days, and ask yourself, by multiplication, how can I get there? Well, that's times 7 times 7. So it would drink 840 gallons in 28 days. Good. So I could make a big table. And that's fine as long as you're adding at constant rate, or you can multiply as long as it's by the top and the bottom, or multiply by the same number, or by 1. Okay, let's take a look at number 4. In 10 minutes, all right, 10 minutes, a heart can beat 700 times. So it's going to beat. At this rate, how many minutes will it take for the heart to beat 140 times? Well, that's interesting. So we're actually decreasing, aren't we? Well, there's many pathways. But you know what I'm going to do? I think I'm just going to do this. Well, if by multiplication I can, I know I'm decreasing, so I'm going to divide it and figure out what did I think it's that 0. Yeah. So actually, look what's happened. For me to go from 700 to here, I actually had to divide by 5. So if I'll divide the top and the bottom by 5. That gives me 2 minutes. So in 2 minutes, heart beats 140 times. There you go. What rate can the heart beat? 140 beats per 2 minutes. Or every minute it beats 70 times. I could even simplify it more, but that's the answer they're asked for. As you can see, so guys, many ways to solve this, many ways to enter these problems, many pathways. Let's go to number 5. The table shows school subjects are favored by groups of students. Predict the number of students out of 400 that would pick science as their favorite. So we're doing science, right, to students. All right. So we have 400, and they want us to predict how many kids are out of 400 will like science. See that? All right. Well, how many like it so far? 3. But 3 out of how many? Is it 3 out of 4? Are we comparing it to English? Are we comparing it to history? No, we're comparing it to all of it, right? Because we're comparing it to all students. So how much is this? That's 10, 20. Oh, look at that. So we know that 3 out of 20, and don't make the mistake of not including this. You need 3 because that's all students. So it's 3 to 20. Well, how did I go from here to here? Well, I multiplied by what? Is that 20? Yeah, so multiply the top by 20, and that would give me 60 students like science. Is that what it is? Take science? Out of a total of 400 students. Let's do another one. Look at this one. Liliana takes 4 breaths every 10 seconds. So this is Liliana. During yoga. At this rate, about how many breaths would it take in 2 minutes? Well, ooh, that's interesting. So look what we have here. Here we have to be really careful. We have 4 breaths every 10 seconds. And now they want to know, well, what is it in 2 minutes? Well, are those the same units? No. So we have to change this to seconds. So that's actually 120 seconds. Ah, look at that. Now that they're the same units, what do I multiply to get it there? Well, again, if you don't, I could make a table, right? Let's go down. I could do this. And as long as I grow at the same constant rate, so if for 4 more breaths, that would be 8, it would be 20 seconds. And for 4 more breaths, that would be 60, is that 60? No, 30 seconds. For 4 more breaths, which is 16, we would be at 40 seconds. And for 4 more breaths, we would be at 50 seconds. Why? Because we're constantly growing by 4 breaths every 10 seconds. But you see how long it's taking? The alternative is I can just set up this proportion, or rates equaling a rate. And since they're telling me they're making the assumption that the rate stays constant, well, 10 times what gives me 120? Times 12. So multiply the top by 12 and I get 48. So it's 48 breaths in 2 minutes, or 128 seconds, 20 seconds. And let's look at this last one. Well, no, this is, yeah, you go look in your newspaper and go find that. But guys, here's what's really important. When you go to set up your work, your equation for your problem, you need to make sure you're comparing the same things. Nada spent $28 on 2 DVDs. See how I'm comparing them? Now I got to compare it to this rate. How much at this rate, which means I'm going to expand it, how much would 5 cost? So does that 5 go here or here? Well, that's 5 DVDs, so it must stay with DVDs. So now we're looking for this. Now, is this an easy pathway? No. So this is obviously, take it down to unit rate. This is 14 over 1. Well, how do I get to 5? Multiply by 5 over 5. All right, guys. See you later.